Hey everyone, I'm David Room and got something a little different for you tonight. So typically when I do these programming streams, I'm working on a cool project, either game programming or my kind of unique process that I have for doing 3D modeling programmatically using Python, Blender, 3D stuff, 3D geometry. That's kind of the stuff that I normally do. Um, Tonight, I wanted to talk about the Python programming language and a common complaint that I have been seeing about it on Twitter. And I recently, I think it was over the weekend, was some discussion about this. And this is a thing that I've seen before, so it's not a new discussion. And for whatever reason, I felt kind of motivated to jump into it this time, and I was kind of curious to understand what people thought about it. And I thought it would be fun to make a live stream to talk about it. So I kind of like teaching about programming. Usually when I'm streaming, I'm kind of just working on my project, and I'm not sort of trying to teach something specific, but this is something that keeps coming up. And I think it would be good to talk about it. So I'm gonna share my screen here, and I'm just gonna close out a bunch of this Python code that I wrote that actually does something cool instead of just um, complaining about the language on Twitter. Um, but just quick for anybody who might be new. I mean, what gives me the authority to talk about this issue? I'm a professional software engineer, machine learning researcher, currently working as a computer vision engineer. I've been using Python professionally for about a decade, and throughout my career, I've used a lot of different programming languages professionally. I've done work with C++. I've done GPU programming with CUDA-C, OpenCL, R, MATLAB, Octave, Fortran, C Sharp, Java, Scala, SQL here and there. And I wouldn't say that I'm like I wouldn't call myself like a world-class expert or anything in any particular programming language, but I use a lot of programming languages and I think a lot about them, and I love different programming languages. So these kind of conversations about like, oh, this language is bad for such and such a reason always kind of bother me. So let's just get into it here, and let's look at the kind of instigating tweet. Shucks, I lost it here. Okay, here we go. So we've got this person here. Why is Python? And they have the classic example of a function being defined and then having a mutable default argument of this empty list. And then the function internally, when you call it, is modifying that list. And they have this commentary, right? Their commentary is, it should be this, but it is in fact this. So actually, before we get too much further into this, let's just make sure that this is right. And let's write this code ourselves and see what it does. So I'm going to just make a new script here that we'll test and run. And for people who are completely new to Python, I'll try to explain this kind of in more detail than I usually would. Sorry if I'm a little frazzled. It's super late here, but I thought I'll jump in and deal with this. I've been wanting to deal with it for a bit. So we'll call this args.py. And I'm going to do all of this code inside of the main program function. That's typically how I write Python code. I don't think for anything... Actually, you know what? Let's not. Let's do it like they have it written, just to make sure that we're up and up here. So we've got our function surprise, my list equals an empty list. Make this a little bit bigger. And notice something right away here. So right away when you write this code in any kind of in any kind of decent IDE, you will get warnings. So I'm using PyCharm. I don't have any special linter plugins or anything installed. It's just whatever, and we get this warning: default argument variable is mutable, and it wants us to replace it with something. Maybe we'll take a look at what it wants us to replace it with in a second, but let's just start. So we have this, and then we're going to take that list and append x, and then surprise, All right, so let's see what this does. I'll make my terminal nice and big here too. Okay. All right, so here's the output of this code. So if you're new to Python, you might be looking at this, you know, what's the big deal? What is expected? Why would you not expect? Let's just go through what's happening. So we have our function. We have a default value to this argument. So basically, default value to an argument just means that you can either fill it in when you're calling the function or not. So you know, I could instead of calling the function with no arguments, I could surprise with another list like this, right? And if we do this, we'll see that list containing the string A printed out. And so in the first call, my list is empty. We print my list, it prints an empty list, and then we append x to it. The second call, my list has that x in it, and that gets printed out, and then another x is appended to it. So we can't really get at this directly, but if we could somehow print out my list here, we would see that it has two x's in it, right? So why do people find this counterintuitive? What's the problem? Well, the problem is that what people are assuming is that when you call this function, they're assuming that if you don't provide an argument, then this expression here will be evaluated when the function is called. So basically, they're expecting that when you call surprise like this, my list will be a new empty list. And then when you call it again, it will be another new empty list. And this is not, in fact, how Python works. When you do these mutable default, well, not mutable default arguments, when you do any default arguments, those those expressions are evaluated when the function is defined, and they persist, they don't change. They're not reassigned, they're not reevaluated. And this kind of throws people off. So I don't really find this counterintuitive, but a lot of people do. And let's kind of look into why, because I decided to poke this bear a little bit, and I got some responses. So I replied, there's no lazy evaluation in Python. The expression of the brackets for the empty list constructs a new list when the function definition is evaluated. If you want to delay evaluation, you have to start wrapping things in lambdas and functions. Also, avoiding default arguments is a good idea for this reason. Linters will warn you for writing code that looks like this. So that was my contribution. Let's take a look at some responses. So people are saying things like shared mutable default params is actually insane. This is why I avoid Python like the plague. So I'm not sure why it's insane. I can understand that people don't understand this behavior, or maybe don't expect it if they're new to Python, but I don't really understand why it's insane. There's definitely times when you would not want to reevaluate an expression. Um, and in Python, you don't really have control over whether things are mutable or not, because it's sort of a scripting language. So if you want to like not mutate things, just don't mutate things, right? And this is kind of like the point that I'm getting at here, right? Or you could just not use mutable default params. That's the other thing you could do. You can just not do it. Some other, I think, yeah, so that was a nice response to the original post that got a lot of likes. Let's take a look at some other. So this guy was kind of interesting because he was like engaging with what I was saying, and he said, but shouldn't that list be valid only within the scope of that function? When a new call is made, shouldn't it instantiate a new list? So this is kind of like, I think what people are expecting is they're expecting it to behave something like this. So let's sort of rewrite this to behave like what people are expecting. So instead of giving it a default value here, we'll give it a default none value, and then say if my list is none, my list equals this, right? So that way, this expression that's creating a new list is evaluated every time the function is run. So that would be like one way to do this if that's the behavior that you wanted. And I responded with another response that I did here. I think we'll jump down and look at that one first. And so this guy's like, but that's idiotic. Now again, like, I have trouble with saying this is idiotic, this is not idiotic. I've used a lot of different programming languages. They all have advantages and disadvantages. I happen to really like Python. It's probably my favorite programming language. And there are things I don't like about it, but I don't feel the need to say like this decision or that decision is idiotic. So he says, but that's idiotic. Obviously, it doesn't construct objects that are inside the function when you evaluate the function definition. How can you claim default parameters must be so? Why would the language designers come up with this foot shooter decision? I know why. So my response here is some explaining about how Python works, and I'm going to kind of go through that with you. So when you load a module that has a function definition, you can kind of think of it as running this code. So it's a little counterintuitive if you're used to working with compiled languages, but you can kind of think of like a function def as code that gets run, right? And what does that code do when you run it? Well, it creates a function. It's kind of like if you use a lambda, right? Let's just throw an exit here. Like if you write some code, and the linter is going to complain because it doesn't like to do this, but like if you say lambda x, print, or like x plus 1, right? When you run this code, right, the result of running this line of code is that this expression, right, evaluates to a lambda function, and a reference to that lambda function is assigned to the variable a. That's what happens when you run this line of code. Now the lambda does not get run, right? Like that's the whole point. You're defining a function that you can run later. But the definition does get run. And like if we run this and we call a, right, with 1, so we get 2, right? That lambda function runs. So you can kind of think of the function definition as doing the same thing, right? When this code is run, it defines a function called, it defines this function that has this argument list and this body, and it assigns it to a variable, or assigns a reference to that function to a variable named surprise. Now, of course, there's a lot of gotchas and little things that go on here, but that's essentially what it's doing. So the point that I'm making here, and I wish this ask grok thing would go away. Let's jump back here. Okay, so expressions, and this is the important thing, and this is I think the key of why I don't find this behavior counterintuitive, is that expressions like default args that are part of the definition are evaluated when that definition is run. So anything that you put in here as like a default arg, like let's add another default arg here that calls a function called build greeting, and let's wrap this around. Right. So let's make our build greeting function here, and so return happy birthday for the greeting, and inside build greeting we'll do the classic printing of got here. So whether we call surprise or not, when we run this guy got here, we get the got here message because this function was called. So any expressions that are inside that function definition are going to be evaluated, right? Now, a lot of people are like, well, why does it have to be that way? And the thing is, like, I've never said that it has to be that way. It's just the way Python is. And there's some good reasons for not being too upset by the fact that that's the way Python is. So what I said here is, like, I didn't say that it must be so, right? It doesn't have to be that way. In fact, we're going to look at something where like there's efforts to change how Python works so it doesn't have to be that way. You can imagine languages that don't work this way, but Python does. And consistently throughout the language, and this is a key thing here, with only a few exceptions, when you execute a line of code that has an expression in it, that expression is evaluated. And with the exception of a couple things like lambdas and short circuiting, and lambdas, thinking about this, I don't know if I would really even include lambdas in that. You cannot have an expression somewhere that does not immediately get evaluated when the statement that it is in gets run. So why would it be different in a function definition? So this guy now comes back with a really good question. He's like, why are lambdas and short circuiting exceptions, right? So, and that's a good question. So obviously, like the body of a lambda is in the same line as that lambda. So, it's not any expressions that are inside there aren't going to get run. I'm not clear on the syntax of like multi-line, like trying to put multiple statements in a lambda, because I don't usually try to do that. But let's just try something here. So, like if we say were to like make a tuple. So we assign a tuple to A that's like 1, 2, 3, print got here, and 4. Right, that got here gets run when we run this code. Now if we put this inside a lambda, so if we say A equals lambda, right, that got here is not run. And but the reason that it's not run is, right, like again, like that's how lambdas work. It's just sort of like, it's like the body of a function in a normal function def. The other situation where you have an expression that basically isn't immediately evaluated is if you're short circuiting. So if we say, so if you start using Boolean operations, right? So like a equals 1, or, and actually I'm not sure what, I think there should be a, yeah, I think this will illustrate my point. So let's go back to our original 1, 2, 3, print got here 4. We run this, we have our got here message. If we do a equals true or this, right, we don't get the got here printout, because when we're evaluating this expression, right, there's going to be a Boolean, this is going to evaluate to a Boolean result because of this logical operator. The first part is true, so it doesn't even need to evaluate the second part. And that's the whole point of short circuiting, is that behavior. If short circuiting didn't behave that way, or lambdas didn't behave that way, they wouldn't be lambdas or short circuiting. It's just necessary the way they are. But the point that I want to press home is, like any other time in Python where you see, like in a line that's getting run, something equals something, that is an expression that is getting immediately evaluated. And that's what people seem to have trouble with. You know, if you call, so here's our kind of behavior, that is the behavior that people want to see here. If we call this with a with an expression, right, like a list that has 1, 2, print got here 3, 4, right? And so let's see here, we'll say in call here, and in function here, right? When we run this, so we have in call first, right? Because this expression is getting evaluated, and then we're calling the function, and then we get the in function printout. And you know, this, so that expression is very obviously getting evaluated first before the function is called. And the same thing would happen whether or not we actually even use that mylist in the function, right? Other languages are lazily evaluated, where that expression wouldn't be evaluated until it's used somewhere, but that's not the way Python works. Anytime you see that sort of equals, you know that what's happening is an expression is getting evaluated, and it's evaluating to some object that exists somewhere on the heap, or whatever you want to call it, and then a reference to that thing is getting assigned to that variable. That's just, it's always the way it works. And you can kind of think of what is going on here as the same kind of thing. It's a little different, because it's like there is associated with this function surprise, there is a variable called mylist, and when the function definition is run, the expression is evaluated, that list object is created, a reference to it is assigned to this variable called mylist, and then if you call surprise without providing that variable, then a reference, like the reference that variable holds, is assigned to mylist inside the function. That's just how it works. You can't rebind it, you can't do anything with it. You can mutate it, right? Because when you have assignment by reference, you can have multiple variables that are pointing to the same thing. That's the other thing that trips people up, as we'll see. Okay, so we're kind of back to our original behavior here. Let's see what some other people said. So, yeah, this guy's like, shouldn't that list be only valid within the scope of that function? When a new call is made, shouldn't instantiate a new list? And again, we saw how you would go about getting that kind of behavior if you wanted it, right? If my list is none, my list equals this. And this is clear, right? This makes it clear what's going on and where that expression is being evaluated. So I linked him to my previous response. He's like, oh, okay, thanks for the explanation. I didn't know this. This guy says it's really a scope problem. Things defined in the function scope should all exist in that scope and not be persisted unless you had some special keyword. It breaks so many basic assumptions about functions. Now, just taking a look at this statement at face value, I think this is fraught with some problems, right? Because you can define things inside a function that have components that are defined elsewhere that persist, right? So you could, for instance, do something like this. You could have a default list that is A, B, C, and then you could even do this behavior, right? So this is kind of like the behavior that he's talking about, where you say maybe, let's see, actually let's do this a little bit differently. So we'll make this be a, yeah, we'll make this be, we'll make this like this. And then, so here, my list is defined inside this function, right? And when and my list does not persist, right? This variable goes away. But the object that it's pointing to has components which do persist. And I could reach inside this thing, right? I could reach inside this thing and mutate it. Nothing prevents me from doing this. Right? Nothing prevents me from doing this, where I think we're missing the print my list, right? Nothing prevents me from doing this, where my list is no longer persisted, but that doesn't prevent components of it from being mutated. Doug's here. He says, not super familiar with this particular battleground, but interesting background. Yeah, it's kind of it's a common complaint of people that people have about Python, and I'm not sure where it comes from. If these people are familiar with JavaScript, and JavaScript has different behavior here. Like I actually don't have very much experience at all with JavaScript. I've done very little front end stuff, and I don't like JavaScript as a language, so I've never used it much. So I don't know if that has some kind of like lazy evaluation or something. We could look at some other languages too to see how they behave. I used to use R a lot, and I believe R was lazily evaluated. But it's been a long time, and I don't have R on this machine right now, so I don't want to test it. Surely these people aren't coming from R though. They're coming from something else. So kind of getting back to this, guys. So he kind of raises this issue that, things that are defined in the function scope shouldn't persist, right? But there's you can still run into issues with mutable stuff, even if it doesn't persist, is the point that I'm trying to make here. And my response is like, sure, but the default arguments are sort of a separate scope, because there's sort of like two scopes here, right? There's the scope of the body of the function, which is sort of like what's instantiated when you call the function, and the scope of the function definition. And there's like one instance of the function definition, but multiple instances of the function body, right? So then he says, it's so weird. Does this mean that even if you pass a list, that list is copied and persisted between calls? And I think this is kind of like starting to get at some deeper confusion here. And I say, no, it's not copied, because in Python everything is passed by reference. So let's take a look at this. So let's go back to the original behavior, which won't even matter here, because we're going to be passing a new list. So we've got our behavior here where we first have this empty list, and then we're printing out a list with X. Let's do this, right? Now we'll call surprise with A twice. Are we going to get different behavior or the same? It's the same, right? Because A is this. What about this? So like, what if we make a separate A and B list? Now we're going to get the desired behavior, right? What about this? What if we assign A to B? This is what trips people up. It's the same behavior as A, because everything is by reference, right? When you assign A to B, what you're saying is, I'm going to assign a reference to the object that A has a reference to B. There's one list, right? And now both A and B are pointing to it. Okay, so Oswald Spangled Banner here says, okay, so it only creates this persistent array if you don't pass one, causing all these weird side effects. Recipe for disaster, it seems. I didn't want to argue it with him anymore, but again, I think I sort of illustrated this. It doesn't only create the persistent array if you don't pass one. It creates the persistent array when you define the function. So again, like, let's say we could make a list factory here, right? Return that empty list and print creating the persistent array, right? And then about to define the function. And don't write code like this, don't put executable statements at the top level of your module, but it's helpful to understand what's going on here. Done defining function. I kind of hope that, just for people who might stumble across this video, that kind of seeing that you can write Python like this gets them thinking. Because Python is very much a scripting language, right? You can often reason very clearly about how Python works just by imagining it being executed line by line. So here we call our list factory. Okay, I'm going to actually make this full screen here so we have a little bit more room to see. And interestingly, the linter is still helping us out, right? Still giving us this warning about a default argument being mutable. So let's clear this and run it. Okay, so about to define the function, right? So again, like we defined this factory function, nothing printed out, obviously, right? Because the body of it isn't run until it's called. Now we're about to define this function, creating the persistent array. So the list factory was called, and done defining the function. So that persistent object is created when the function is defined. Let's see what Mr. Hidden Reply has to say here. Python being purely passed by reference has made me want to break my keyboard multiple times. Well, I don't know where this guy's coming. I'm not going to click on him right now because he's NSFW, but scripting languages are almost always like passed by reference. I believe, like, so just talking about R, if I remember right, R I think was actually passed by value, but it was lazily evaluated or something. So there are gotchas, but like, again, I think unless you're working with a language like Rust or C or C++, like you aren't going to be like passing things by value. I don't know, maybe this guy is like a Go programmer or something. I don't know. It's just the in many of these garbage collected languages, the sort of default mode of operation is passing by reference. So to me, that's just not unintuitive. Garbage collected language, allocate stuff, pass references around, don't worry about it, whatever. One quick thing that I just wanted to get at is, like, if you didn't, so we had this, let's see if I can bring it back here. We had this situation here where we had like this default list. So I said there's, even if you do this kind of thing, there's still some gotchas where you could be like mutating, you could still be mutating a shared thing. How do you deal with that? Well, because things are passed by reference, when you assign, you're copying references, you're not copying objects. How do you deal with this? Well, you have to make deep copies, and making deep copies is just as easy. Well, not deep copies, but making copies is just as easy as, wrapping another constructor around something. So, like, if you have a list, and then you call it with, or so let's go back to this egg here. So if we do A and B, and then we run it, whoops. Oh, so we'll also do this as default. That's right. So here we have the same problem, right, where even though we have our nice behavior, because we're passing a list in and that list is being shared, we're getting our data structure to be modified. If you wrap a list around this, right, it still kind of has the same problem. We don't get the second X, but we do get the first X. So you just have to do some kind of deeper copy. You could do like a, depending on, like, if you knew what kind of data structure, you could just do a simple for comprehension like that to copy things. And then I don't like to use these. I'm going to see if I can even remember copy. So I think you could do this, copy. I think this does a deep copy. No. See, I don't actually, yeah, there we go, deep copy. So that is going to automatically go in and do a deep copy. But I don't like to use deep copy, because most of the time when I write code, I'm actually writing functional code where I'm not mutating things. I'm not mutating the arguments that I'm calling functions with inside the function. And also, I don't use default args at all, mutable or not. I'll probably get into that sometime in another stream. But I think default arguments are a really good way to shoot yourself in the foot, and there's good ways to do the things that they do for you without, while avoiding some of those foot guns or whatever you want to call it. So let's take a look at if there's anything else. Okay, so this guy says the same kind of thing. It doesn't execute the body of the function when it evaluates the function. Why should it be any different for default args? Again, because it does execute the function definition, and that's where the expressions that are evaluated to become the objects that are the default args are, right? Those things have to be somewhere, and these people, they want that to happen when the function is called, not when it's defined. And you know, you could imagine a language that works that way, but that's just not how Python works. And I don't struggle with it because I think throughout the language, when you have a line of code that is run, and I think it's reasonable / correct to think of the function definition as a line of code that gets run, expressions in that line of code, with only a couple of exceptions, are immediately evaluated. Yeah, so another person says it could have been implemented this way, but I think for ease of implementation, it wasn't. And I think that's exactly right. Like, Python is a scripting language. It's very straightforward the way, that things are evaluated and run. And I think that's just why it is the way it is. This guy has an interesting point. So he says ambiguity either way. Let's take a look at this guy's code. So he says we could say define x to be 1, and then def a equals x, and print a. Actually, wait, before I get too far into this, I'm going to comment this out because I think there might be some other stuff that I want to show here. So I want to keep our original example here. Okay. So he says ambiguity either way. So he wants to say x equals 1, def f a equals x, print a. And then if we call x, and then if we say x equals 2, and then call f, should the output be 1 or 2? So what do you think? Should the output be 1 or 2? Well, what I said is the output should be 1. Let's see if I'm right. Yes, the output is 1. The expression x is evaluated when the function definition is evaluated, and from that point forward, when a default value of a is needed, it will be the same ID as the original x. When you reassign x, it's a new variable with a different ID. Let's take a look at this. So let's print a and print the ID of a and the ID of x. Actually, let's do the ID of x first and then the ID of a. So this ID here is a. Actually, here, we'll just print the ID of x here. Actually, we'll just make this explicit so we don't get ourselves confused. So the original ID, and for people who don't know what ID is how you get the reference of a variable. So it's like the address or unique ID of the object that that variable is pointing to or referencing. So we'll just do a nice f string here. So we'll do a x. Sorry, I'm having to zoom out here a little bit. Is it going to complain at me for... Oh, that's interesting. Let's see. This might not... Oh, no. There it is. Okay. So let's take a look at this. So ID of X is this thing that ends in 7048. And just for clarity, let's call this twice. Okay, so when we call it the first time, ID of X and ID of A are the same. So both X and A are pointing to the same object, and it's crazy, but like that integer 1 value is an object in Python. It's an object, it has a class, etc. They're pointing to this that has this address. When we reassign X, right, now X has a different ID, but A has that same ID as the original X, right? So now, so this is what he says. There's something unintuitive with lists. This is kind of funny because he brought up this case where it's ambiguous, you know, just with primitives, but you know everything's an object. And he says there's something unintuitive with lists. When you say x equals x plus 1, it feels like you're modifying the value, even though you're actually changing what address it points to. It leads to wrong assumptions when you actually mutate a list. Yeah. But here's the thing. So in my response is what I say. Some things are immutable and some things are mutable. This is something that you just have to deal with. And it's not unique to Python, right? In any language, you're going to have data structure, unless it's a pure functional language where there's no mutation at all. You're going to have some data structures that are mutable and some data structures that are immutable. The thing is, though, and what I point out here is that Python deals with it consistently. Assignment is always by reference unless you're assigning into something. And when you're assigning into something, the equals is actually syntactic sugar for a method that is getting called on that thing, right? So really, anytime that you see equals and you're not like assigning, and you're not like, say you have like a list or something, anytime you have equals and you don't see that bracket, you know, on the other side, you're not mutating, you're copying a reference, right? That's just a fact. So it's you know, on the one hand it might be unintuitive, but on the other hand, Python behaves very consistently and uses its syntax consistently, right? You don't have some cases where equals is copying, some cases where equals is copying references. You know, you don't have a pointer value distinction like you do in C++ or whatever. I'm living in C++ land right now in my job, and it's kind of refreshing to come back to Python just because it's so much easier to reason about what's happening. Okay, so I think that was everybody who interacted with me about this. I was pretty satisfied because a couple of these guys really came out swinging with, it's like, oh, that's idiotic, and I was kind of able to say, okay, but you know, it's just sort of how Python works and it's consistent. There was another guy who commented on this. He said there's a category of programming language trivia like this that interviewers love to ask about that I think people put too much importance on. If you're writing code that requires such a deep understanding of the Python interpreter that you can explain this, you're writing bad code. Now, I disagree with that. So I said, disagree. It's pretty fundamental to how Python works that variables are references and assignment copies references. And if you've written Python code and you've used a linter, you've probably gotten warnings about mutable default args. People only find this confusing because they don't understand the fundamentals of the language. I guess you might be able to manage without understanding this stuff, but it seems fair to assess in an interview. And my position about programming interviews is like, you know, they shouldn't be gotchas, but if you're hiring somebody to be a Python programmer and they're explaining to have they're saying I have experience in Python, you know, I think they should know how these things work. Like that previous example that we just looked at, where it's like, oh, it's ambiguous. Is it going to print one? Is it going to print two? I mean, I knew what it printed without having to write the Python code because I'm familiar with how the language works, and the language actually works consistently. It's not some big trick question or gotcha. So this guy says that's fair. Well, I understand knowing the Python interpreter's behavior is useful. Those interview questions like, oh, here's this really tricky bit of code, whatever, he's kind of like, the real world answer is you shouldn't be doing that. And I agree. I don't really even think that you should use default arguments at all, right? So I agree with that. But but it is still a fact of how the language works that if you have experience or are going to be using the language, you should understand this guy kind of has the that opinion as well. This guy has a good point too. I don't think you shouldn't be doing that. Is at all obvious here. Empty arrays, the default parameter value seems reasonable. Appending an item to array seems reasonable. Face value of this code seems perfectly fine, but it's not. I mean, that's what everybody's arguing. Again, there's different takes, like you shouldn't be doing that. Like I would argue you shouldn't be doing that because of these reasons. I would argue that you shouldn't be doing that because I don't want to see default arguments and I don't want to see mutation. Right? I'd rather just have pure functional code. But at the same time, I mean, this isn't rocket surgery. It's pretty basic facts of how the Python language works. I think there was somebody else that was, oh yeah, this guy thinks I'm an idiot. This has nothing to do with pass by reference, because Python could just assign a reference to a new array each time the function is called instead of insanely assigning the same reference over and over to a singular array it creates when it evaluates the function definition. Well, yeah, again, like it could do that, but it's not what it does. There's languages that have lazily evaluated stuff, but that's not how Python works. And I mean, if you want to argue on Twitter till you're blue in the face that a programming language shouldn't work the way it does, I mean, that's fine. It's incorrect though that it doesn't have anything to do with paths by reference because I mean there's different reasons why you might expect this behavior to be different than what it is. One reason would be, like this guy, you think that it should just be obvious that the expression for default args is evaluated every time the function is called. Another reason why you might not is that you might think that there's like some kind of pass by value going on where things like lists should be copied automatically. Again, this doesn't make a whole lot of sense to me, but people seem to get tripped up on this a lot. So I think it does have something to do with pass by reference, right? Let's see here. Oh, here's this guy again. I disagree with OP, but it seems to have nothing to do with variables being references. I mean, see, again, I think it does. It does have something to do with things being references because when that expression is evaluated, it's only evaluated once, and then further times that it's used, those are references to the original, right? Maybe not pass by reference, but yeah. Okay, yeah, here we go. This has nothing to do with references. Every other bit of code in a function is run when the function is called, not when it's defined. Yeah, that's correct, but this code is not in the function, it's in the function definition. I know this is hard for people, but that's just the way it is. And it's like, I guess there's only so many ways I can say there's reasons for making the distinction. Like I like to think of it as this line of code is a line that gets run, um, and then its action is to define. It kind of like skips over the body of the function, right? But every expression in here is evaluated. Another way you could think of it is like, you know, the default values for the arguments are not in the body of the function, right? They're kind of like a prototype of values that are coming in. So it sort of makes sense that they would be evaluated outside of the body of the function. I mean, again, like if you just have this hang up where you're like, there's no way that this makes sense to me, I guess it's a lost cause, but there's a lot of reasons I think that you could make that distinction between the body of the function and the function definition. Um, let's see what this guy says. I actually muted this a long time before I read some of these replies. So just treatment of values and references wouldn't matter if default args aren't in the function at definition time. Aren't in the function object at definition time. This plus the arg being immutable ref can give the observed behavior. Since the immutable ref is stuck in the function definition, I don't really see how that's fundamental. Yeah, and I mean, so again, like the point that I'm making here is less about the specific behavior of where this is defined, and more about like the general idea that that things are objects, and when you assign things, they're copied. So like maybe this is another way to think about this, right? So what everybody wants is everybody wants this to be an expression that's evaluated when the function is called, right? But this is only an expression when the function is being defined. It instantly turns into an object that is assigned by copying a reference to a sort of placeholder mylist that's used when somebody doesn't pass a mylist, right? Now, if some part of that worked differently, right? Like if say that assignment, like so here's something that could happen, right? That expression could be evaluated at function definition time, but instead of being copied by reference every time, it was deep copied. Now, I don't know how much sense that would make, but that would be one way to do it, right? Like instead of reevaluating the expression, it could be evaluated once and then deep copied, right? But that's not what's going on. And the reason that you know it's not going on is like no other point in the Python programming language do you have this case where you have something that looks like a variable and an equal sign and something that looks like an expression that when you run it does something other than evaluate the expression and then assign a reference to that thing that was created as the result of the evaluation to that variable, right? This isn't some exception. It's like like everything else in the language works the same way. So that's the point that I was getting at, and I think that's about all there is to say about it, unless I were to start digging into other people's replies to these things, and I don't really want to get into that. So that's basically what I wanted to show. Oh, one other thing. So there is some effort to add a special syntax for late bound function argument defaults. So this proposes adding this little arrow syntax, and then that makes this be an expression that gets evaluated when the function is called. And there's some nice uses for this. So like to automatically evaluate an expression that involves another argument that's being passed. That's kind of cool. Um, yeah, I mean, to me, it just kind of clutters up things, and I think if you want that behavior, right, the most obvious way to get it is assign none, and then just if my list is none, my list equals that. And then I think it's very hard. It would be very hard for anybody familiar with this issue or not to look at this code and not see what's going on. Obviously, now this expression is going to be evaluated when the function is called, and it's only going to be evaluated if you don't pass that. 1 second. So that's kind of what I would recommend. And there's sort of a philosophy in Python. Let me see if I can find it. There's like the Zen of Python thing, and one of the things there is like explicit is better than implicit, right? So I think Python leans, and good Python code kind of leans more towards, don't get clever, just write things out. It's not bad to just write out this code instead of wishing that there was a language feature that did lazily evaluated expressions in one case when they don't exist anywhere else in the language, or anywhere, at least anywhere else. I could be wrong. I like I said, I'm not like a world class expert in Python, and I admit that there's sort of like a specific, and I intentionally do this. I use sort of a specific subset of the language. I don't like default arguments at all. But like in the subset of the language that I use, right, and I can reason about, well enough to predict some of these tricky cases that these people are talking about. There's no other part of the language where you have these kind of lazily evaluated expressions that they wish seem to exist in this particular case. So that's all I wanted to talk about. This is kind of an interesting conversation to have. One I've seen come up before. It's kind of fun to dive in. At least got a, oh, that's interesting. I wasn't familiar with that response from a couple people. And I think, like, for me, honestly, I don't find the real behavior unintuitive or inconsistent. So hopefully, maybe if you're somebody who has to work with Python, maybe you don't like it. I get it. We all have to, do things in our code sometimes that we don't like. At least maybe I've provided you a way to think about why mutable default args, or just default args in general, kind of work the way they do. So I hope this is useful. And if you're interested in my project, usually I stream once or twice a week and do cool stuff like 3D modeling, game development, some Blender stuff too, with Python. So if you're interested in that, make sure to subscribe and watch for live streams and other videos. So thanks everyone for watching, and thanks Doug for hanging out as usual, and have a good night.